Today we're going to start a new unit. In this unit, we're going to talk about matrices. There's only going to be 4 lessons, so it's a shorter unit for us. Yeah, so we're just going to go through these lessons. Matrix is probably new to most of you. A matrix is just a way of organizing information. It's basically a table. It's basically a table of information.
Do we get to watch The Matrix?
Has nothing to do with the movie The Matrix. So, no, we won't be watching that. Because that has nothing to do with it.
I was just thinking of like a movie. Can we
Yeah.
still watch like a certain movie? I don't know, like Finding Nemo or something?
Nope, probably not. When we read a matrix, we say that it has things in it called elements. When we give the dimensions of a matrix, we say the number of rows that there are first, and rows are sideways things. Okay, so these are our rows. And then the number of columns after that, so these are our columns.
Columns go up and down.
So when we say the dimensions of it, we tell first how many rows there are, then how many columns there are. So our first example wants us to display some information in a matrix. So we are told that Jessica does a survey at 4 different desserts at 3 restaurants. You can set up your matrix either way and it doesn't matter, you just need to kind of say what's what. So what I'm going to do is we use these little square brackety things to denote a matrix. I'm going to have my restaurants kind of going across the top here. And then I'm going to have the desserts going down the side. So she's got apple pie. She's got a sundae. She's got cobbler. And she's got ice cream cone. Matrices, we don't usually label what's what, but to kind of help make sure that everything's going in the right spot, that can be helpful while you're setting it up. But then, in general, when we see a matrix, all we see is the square brackets and all the numbers inside. It doesn't necessarily tell us what things are. In a context, it will in some way tell us, but it's not labeled like a table, usually. That's really what they are. It's just tables of numbers. So, at restaurant A, the pie is $2.25. And the sundae is $2.95. And the cobbler is $1.95. And the ice cream cone is $1.10. At restaurant B, pie is $2.75. Sundae is $3.45. Cobbler is $2.50. And ice cream is $1.65. And at C, pie is $2.40. Brownie, sundae is $2.70. Cobbler is $2.35. And ice cream cone is $1.15. Just kind of fill in all the information into a table type arrangement. And we're just going to call it a matrix and put those little square things around it. In the same part, it says use symbol to represent the price of a brownie sundae at restaurant C. So we have to find what thing we're talking about there. So at restaurant C, brownie sundae is this one. Then the way that we're going to denote this is elements are denoted by the letter A. I don't know why. That's just what they are. So element A, and then we're going to tell what row it's in. So it's in row 2, because remember rows go horizontally, so it's the second one down. And then what column it's in. And it's in column 3. So that's how we would denote where you would find that piece of information. We always use the letter A, the row number first, and then the column number. Questions? All right, so then our other problems for today are doing some starting arithmetic with them.
Wait, what? Wait, go back.
Can't. I can go back to the question, but the writing's
okay.
going to be
No, you're
gone.
Okay.
So, I'm like,
Yeah.
it's gone.
I can't.
Okay, she said A23.
Yeah.
And it was a brunch Sunday at restaurant C.
Yep.
But isn't restaurant C like, why would it be A?
It's always letter A. That just denotes that we're talking about an element. Then the 2 and the 3 tell us what row and what column that information is in. So it's in the second row of the third column.
Is that because like sometimes they might be asking for more than one thing and then you would go like B? And
Yeah. Well, we just always use the letter A. I don't know why. It's always A, and then we just give the numbers of the row and the column. Somebody decided we're going to call elements A's. To add or subtract two matrices, you just add and subtract the matching elements. So if I want to add these up, I'm going to add together the -2 and the -6. I get -8. Then I'm going to add together the 0 and the 7 and I get 7. Then I'm going to add together the 1 and the -1 and I get 0. And then I'm going to add together the 0 and the 4 and I get 4. And the 5 and the -3 and I get 2. And the -8 and the 10 and I get 2. And that's our answer. And it looks like a rainbow.
Oh, that's so great.
To subtract is exactly the same. So to be able to subtract, we're going to take first things and subtract them. And then the next thing in there. And subtract it, be careful here, because it's 4 minus -2. So that really means 6, right? So be careful when you're subtracting that you're really subtracting. Minus and negative turns into adding. -1 minus -6 is 5. 3 minus 1 is 2. 0 minus 5 is -5. And -4 minus -5 is +1. So to be able to add and subtract matrices, they have to have the same dimensions because we have to have those exact matching terms. So if the rows and the dimensions don't match, you can't do it. And so in your homework, there might be some questions that ask you to add or subtract matrices, and it's possible for you to say that it's not possible. Okay? The rows and the columns have to exactly line up so that we can take term by term and add them and add them and add them. Okay, so for example, we could not, if I asked you to, do matrix A plus matrix C, because they don't match, they're not the same thing. Okay, so on your homework, it's okay to say that it's not possible to do. To multiply by a scalar, so this one asks us to find 3a, we call just a number a scalar. Yeah.
I'm sorry. What exactly would make it not possible?
If the rows and the columns don't line up. So like matrix A had 3 things going across and 2 things going down, whereas matrix C,
Oh, okay. That's what I thought. But
0, -4. So if they don't line up, if they're not exactly the same size and shape, then we can't do it. So to multiply by a scalar, which is just a number, that's just a fancy way of saying a plain number. So if I want to take a matrix, and in this one I want to take this matrix named A, and I want to multiply it by 3, you just multiply everything in it by 3. So -12, 3.
So can you multiply different matrices with different dimensions?
Well, this isn't talking about multiplying a matrix by a matrix yet. We'll talk about that in our next lesson. That becomes a trickier thing. This is just multiplying a matrix by a number.
On our homework, are we allowed to use our calculator if we know how to do that?
Yes. And if you don't know how to do that, we will learn that when we learn our next lesson about multiplying them, because I'm not going to make you multiply them by hand. I'll show you how and why it works the way it does, but then we will be using our calculators to do matrix arithmetic. With adding and subtracting, to be honest, I don't even usually take the time to enter it in my calculator because the amount of time it takes me to enter it, I could actually just work it out faster by hand. But once we get into multiplying, then I do. And so in the next lesson, I will teach you how to enter this information into your calculator. All right? All right, that's it for lesson 1.